好了，我们就说是大家都知道啊，这2年 IoT 的概念是越来越火啊，就说是，但是我想可能很多开发者都在想，我一个做软件的怎么就去搞硬件呢？那么我们有什么方法让我做硬件做得更嗨、更爽一点？所以说今天我们很荣幸的邀请到了来自于微软的一位25年一直奋战在一线的一位开发老兵，让我们掌声欢迎 Dev。
Good morning. It's great to be here. I'd like to add my welcome to you all for making it along here this weekend to PyCon 2019. It's an awesome place to be. My name is David Glover. I'm a Microsoft Cloud Developer Advocate. And actually, while I remember, I've been asked to speak slowly because I understand the translator has crashed. So I will promise to try and speak a bit slower. So it's amazing to be here. Now, before I get started, I thought it would be fun to take a photo and also to get you all to stand up, because you've probably been sitting for the last hour or so. So can I get you all to stand up? Stand up. And can I get you to wave? That's awesome. So I thought it'd be good for you all to stand up and just stretch for a moment. So as I said, this is a great place to be. Python is an awesome language, and there's lots to learn. So what I would challenge you all over the next 2 days is to make sure that you go to sessions and learn lots of things, but also to meet new people, to say hello to somebody you've not met. And I challenge you to meet 20 new people over the next couple of days. So I wanted to start here. This year is the 50th anniversary of the Apollo moon landing. Has anyone followed the Apollo moon landing? So really exciting. When I was kind of growing up and a very small child, I remember some of the moon landings or the space program, and I was really inspired by it. And I think it was one of those things that got me really interested in technology. I just thought, wow, we've actually got somebody on the moon. In that case, it was a man on the moon, and it was just amazing what man could achieve. So what I thought I'd bring up here is, behind me is a woman called Margaret Hamilton. And she was responsible for the software that was driving the Apollo guidance system. So it was the navigation, or the GPS, of the Apollo mission to get it to land on the moon. And back then, it was an incredibly difficult and complex piece of software. And not only was it complex, but it was hugely expensive. It was very expensive to be able to go and build these software systems to go and land a person on the moon. So that was one of the things that really, it was very difficult and very expensive to be able to go and do that, and very complex. The thing that's changed today is it now has got remarkably simple. So has anybody heard of this thing called a CubeSat? Anyone heard of a CubeSat? So a CubeSat is a small satellite that goes up into low orbit around the Earth. And they cost about 30,000 American dollars to send up into space. And the really amazing thing about these things is that this thing here is a Raspberry Pi. And that Raspberry Pi is running Python. So now you can go and build a system, send it up into space, It's a Raspberry Pi, and it's running Python, and kids at school, children at school, can now be writing Python code and sending it up into space and then doing space experiments. So it's just amazing how we've come from 50 years ago, when it was incredibly complex to go and build software for man to go to the moon, and now we've got these CubeSats which are cheap. It's got a Raspberry Pi, and you can go and build it in Python. So much has changed in that amount of time. And the great thing about it is you don't have to have a huge budget. You don't have to be a big organization or government now to send a rocket up into space. So that's really changed what's happened. The other big change is open source software. These CubeSats are all built on open source software. So we can all learn from each other and share things that are happening. So the Raspberry Pi runs a version of Linux. Python is open source, and people are building applications which are also open source. So it's really changed the way in which we build software, and really Python enables you to do just amazing things. Really, that's kind of the main thing I wanted to say. Am I speaking about the right speed? Am I speaking okay? Not too fast? Okay. Now, I've been a software developer forever. Well, it certainly is for as long as I can remember. When I was a teenager, I started building software. And the software that I built all had curly brackets. So I used to program in C and C++, and all these languages had big curly braces. And that was how you kind of set a block of code. And I remember the first time that I looked at Python, and I thought, this language is terrible. I hate it, because it doesn't have curly braces. And it took me a while to figure out that not having curly braces was a really good thing. And the thing I love about Python is its simplicity, and the last speaker talked about this, was its beauty. And I love how clear you can define the code in Python. So I've gone from somebody who thought Python was just awful because it didn't have curly braces, to now I think it's just a wonderful language, and it's the language that I use most often. I started doing Python code mostly around OpenCV. So does anyone else here use OpenCV? Okay, so it's a really amazing computer vision framework that works really well with Python. And that's really how I started using Python, because I realized I could do so much more with computer vision that if I went and wrote it in other languages, I wrote a mountain of code, lots and lots of code. So Python enabled me to do that really easily. Now, I got into Python also because I love doing things around the Internet of Things, also known as embedded computing or microcontrollers. So you'll see I've got embedded there. And that, again, was one of the areas that I got into Python, because I loved going building software on small devices. And it used to be the case that I could only build software on small devices using C and C++. And it was very prone to errors and problems. And recently, you can now get what's called MicroPython or CircuitPython. Has anyone tried MicroPython or CircuitPython? So there's a few hands with those. So that is a version of Python that has been highly optimized to run on a very small microcontroller. So this type of device over here, sorry, that's behind my head and you can't see it. But over there, there is a very small piece of silicon, and that is now capable of running MicroPython. The other areas where Python has been used a lot is obviously around education. So with Raspberry Pis, and again, I'm hoping that some of you will have Raspberry Pis because they're an amazing device for being able to build software. But also building web applications is an amazing place to be building Python. So using frameworks like Flask just really enables you to go and build web applications really easily, much more easily in other languages, I feel. Other areas where Python are being used is around automation. So for things like DevOps, if you've heard of DevOps, basically be automating processes if you're going to build things or you're automating adding users to systems and things like that. One of the new areas, of course, is machine learning. And that is where a lot of people and a lot of investment is going into making machine learning much easier using languages like Python. And then finally, things like data analysis. Again, using Python has become extremely popular. And I think this year and the last year, Python has been the fastest growing language, kind of out of all the languages. So if you're learning Python, the really great thing about it is you can use it everywhere, from the smallest pieces of silicon to all the way up to really large systems running data analysis or doing machine learning. So you can use it that whole way. So that is the beauty of Python, is you can use it in so many different places. So it's really worthwhile to invest time to learn about Python. So the theme for my talk and my demo is around using technology for a better life. And everything I'm going to show you, I've written in Python. It's all open source, and you can use the Azure services for free. And I've tested the services, and you can use them from China too. So that's kind of how that works. So that's the key thing about it. So everything I'm going to show you in my demos are all Python. It's all open source frameworks, and you can use the services for free on Azure. So the theme for my demos is going to be about using technology for a better life. And it's something that we can all relate to. And the example I'm going to show you is a shopping application for vision impaired people, so for blind people or vision impaired people. And how can we make their life easier with technology? So that's kind of what this talk and what my demos are going to be about. So my demo is split up into 3 segments. So the first part I'm going to talk about is this thing called Intelligent Edge, and how we can run machine learning models on smart devices like our mobile phones or Raspberry Pis or our computers. So that's going to be the first part of this demo. The second part I'm going to talk about is what I've called cloud integration. How can I get the data from this, in this case, this mobile application, how can I get that data up into the cloud? And I'll do the cloud up there because, of course, the cloud's somewhere up there. And the last part I'm going to talk about is some work that we're doing around Jupyter notebooks. How many people here use Jupyter notebooks? Okay, that's what I thought. How many is that the cable to the speaker is not long enough, so we're playing the sound on another computer. Okay, so this time I'm going to press the key.
启动扫描仪。你扫描了一个橘子。你扫描了一根香蕉。你扫描了一个红苹果。你扫描了一个青苹果。
I'm glad you got a good laugh. That's funny. But hopefully you understand that we had to play the sound on another computer because the cable's not long enough to plug into my computer. So the way that I did that, that's really funny. And I'm glad you laughed. So the way that demo worked is I trained a machine learning model using something called Azure Custom Vision. And Azure Custom Vision makes it really easy to go and build an image classification system. And I'm going to show you how this works. And the beauty is you don't need to be a deep mathematician or a data scientist or someone who spent years doing this thing. We make it really easy to go and do this. Now, the example that I've shown you is quite a simple example. It's just, obviously, I'm just classifying types of fruit. But there are people using custom vision to go and do things like find leaks in oil wells or pipelines that are shipping oil. And what they do is they fly a drone down across the pipeline, taking photos across the pipeline, and then they can detect leaks. So they've taught the machine learning models what a leak looks like in the pipeline. The other place that people do this is manufacturing processes. So trying to find a place where there may be a defect in a product. And we've got some partners in Germany where they manufacture, and they're using this as goods go down a conveyor belt. They take a photo of the good, of the product, and they can figure out if that product is faulty by taking a photo and then running that through a machine learning model. So that's how I did the vision. And what custom vision does is it gives you a probability. So you can see over here that the custom vision is telling me that the probability of that being an orange is 99.9%. So really high. And I'll show you how that works. Now, the way that I did the speech is I did two things. I used Azure Speech Services, and it did language translation. So it translated from English to Mandarin. And I just said, here's the English text. It converted to Mandarin and then gave me back the characters for that. I then passed it to the speech engine, the text-to-speech engine, and that converted it into speech, into audio. So that's how it worked. Now, Mandarin, we have something called what they're called neural voices. So they're called deep neural network voices, and we get really good quality Mandarin out of these, Mandarin speech out of this service. So it's pretty nice. So I'm going to go through a demo on how this all works. So what I've done here is I've gone into the Custom Vision portal, the web portal, and I've started up. And the first thing you would have noticed is that there were a lot of images there. Whoops, sorry about that. Okay, so these are all the images. And you'll see that they have tags. So the next slide, you'll see that I've clicked on red apples, and then I'm seeing all the red apples. I'm next going to click on the oranges, and you can see that these are all the images that have been labeled oranges. What I can do now is I can go and add in new tags, and what I can do is I can select an existing tag, or I can create a new tag. In this case, I've tagged it grapes. So training these models is as simple as finding a whole lot of images of the thing that you want, and then you basically say, these are oranges, or these are bananas, or these are apples. So that's how that works. And then when I've set up all this, I can train the model. And there are two types of training. You can do a fast train, which will go through and train, give a very quick version of that training, or I can do an advanced training, which takes a more deeper training and a more accurate model. So what this will do now is that this will go off and build the machine learning model for me. So it's beautifully simple. So you can see what I'm doing now is I'm going to test this case here. I'm testing this, and you'll see over here that it said it's a red apple, and I'm 98% sure it is a red apple. And I'm going to test something else. I'm going to test an orange, and you can see that it's come back and it said it's 99% sure it's a banana. And the same is true for a bunch of bananas. So that is the beauty of it, is that you can just give it all these images, and you basically tag those images and tell the system what they are. And then what I can do, and you can see I've got what are called iterations of these machine learning models. What I can then do is I can expose that machine learning model on the web, and in this case I could make it an HTTP endpoint. So I could do an HTTP post. In this case, I could post it to that URL. So I could send the photo up into the cloud to that URL, and then I could have the image classified, and I would get back a JSON object that would tell me what that system is, or what that item is that's been scanned. What you can also do is that you can export these models. So you can export the models to what's called Core ML. So you use Core ML on an iPhone. You can export out to iOS. You can export these models to TensorFlow, so on Android, to Onyx on Windows, and to Docker. How many people here use Docker? Okay, great. So this is downloading. This is going to download the machine learning model and a Docker template and a Python application. So I can now use this machine learning offline. So I don't need to be connected to the cloud, and I can use it for free. So I don't have to keep paying Microsoft every time I want to go and use the model. So what I did then is I downloaded the model. So now that I've downloaded that model out of Custom Vision, I've opened that model and that project that I downloaded from Custom Vision in Visual Studio Code. How many people are using Visual Studio Code? Okay, that's great. If you're not, you should be, because it's great. And it's free. And it runs on Linux and Mac and Windows, and it's a very popular open source project. Okay, so I've downloaded the project from Custom Vision, and I've opened that project in Visual Studio. And you'll see that it's brought down the Docker file, and you'll see I'm building this project, or this Docker image of Python 3.5 in this case, it gives me all the requirements, the app directory, and I'll just start this up again so you can see it's on Python 3. There go the requirements for the Python application. What it builds for me is a Flask application. So there's a template which basically gives you a Flask application. So you have an HTTP endpoint for this. So you'll see the endpoint comes up there. So I can do a post to that Docker image, and I can send an image there and have it tested. You can see that these are all the tags. So these are the tags that when I went and created my custom vision, you remember I had bananas, red apples, grapes, oranges, and things like that. So those are the tags that I set up in custom vision. It brings down the machine learning model, and this is the Python application which is running TensorFlow. So it brings down a TensorFlow model, and that's how this thing is running. So the beauty of this is you can now run this offline. So what I'm going to do here is I'm using something called Postman. So Postman is a really good way of testing an HTTP endpoint. So I'm using There is another one. Thank you. And so what that's done is I'm now going to send up an image. I'm going to send an image to the custom vision app, which is now running inside the Docker container. And you can see now that I've sending this image to the Docker container, and you'll see that the Docker has responded back with a tag name which says it's a banana, and the probability that it's 1. So it's 100% sure that was a banana that was scanned. So the main thing I wanted to get across was that you can do custom vision models, really simple to build. You can execute those custom vision models in the cloud, or you can export them and download them and use them on mobile phone applications and things like that. Okay, so the next thing I'm going to talk about is something called cloud integration. And what this section is going to be about is how do I get the data that I got when I scanned, in this case, the banana or a bit of fruit, how do I get that data up into the cloud so I can do some data analysis? So the way this works is on the device that is doing the scanning, it is going to send a JSON message. So a simple packet of data, a simple string of data, of JSON data, up to the cloud, and it's sending it something called Azure IoT. Now, when that message arrives in Azure IoT, it gets picked up by something called a function. And a function is what's called an event-driven piece of code. So the message arrives, and then the function says, there's a new message. It starts up, and it executes. And in this case, what I'm going to do is I'm going to write that message into some storage, into a table in Azure. And you can see over here, I'm just keeping a table of the tags and how many were scanned. So we have these things called Azure Functions. And Azure Functions are an open source project which are an implementation of serverless. Now, I don't know if you've heard of serverless, but if you haven't, it's a very popular way of running code in the cloud. And the beauty of serverless is you don't have to worry about infrastructure. So I'll just move out of the way. So you don't have to worry about infrastructure or setting up any computers to go and run this code that executes. The other beauty of running Python as Python functions is that they scale. So maybe today you've just got 1 or 2 events that are happening, but maybe you're writing an application which might need to scale up to many millions of executions. It will scale for you automatically. Now you can run these Python functions inside Azure. You can run 2 million of them, of executions of your code for free per month. So you can do an awful lot inside Azure using Python functions and run those for free. It's very cheap. So that's the kind of the beauty behind this. And you can see up here that what I've got this is just up in the cloud, up in Azure. You can see that there goes my Python function. And literally all it's doing is when a message comes in from my scanner, a JSON message is sent to the cloud, this code executes and then writes it into some table storage. Okay, is that fairly clear? Hopefully that's clear what's going on. Okay, so the last thing I'm going to talk about is what you can do around data analysis, and particularly around debugging. So I saw lots of hands go up for Jupyter notebooks. And they are just a great place for sharing data and things like that. So the demo that I'm going to show is, now that I've got this data up in the cloud, so I know you probably can't necessarily see that, but over here I've got my table of data that I've got up in the cloud now, and what I'm going to do is I'm going to analyze that data with Jupyter notebooks, and then I'm going to show you how you can debug a Jupyter notebook, because debugging Jupyter notebooks can be really quite difficult. So what I've got here okay, so you're all familiar, hopefully, with Jupyter notebooks, and you can see that I've got some Jupyter code executing. So what's happening here is that cell number 4, in this case, what I've done is I've queried the table in Azure, and it's brought back a collection or a list of JSON objects from the storage. So that's just basically all the data that's living up inside Azure for this application. And then what I want to be able to do, so that's the JSON data, then what I want to be able to do is plot that data. So I want to be able to iterate over that data, and then I'm just using matplotlib to execute that. So I'm going to execute this final cell, and then I've got the dreaded type error. How many people have had this problem in Jupyter notebooks? This happened to me when I was doing a demo, and it was really embarrassing. And so I swore that I was going to learn how to debug Jupyter notebooks. So I looked at this, and I thought, I have no idea what is happening, what's going on with my code. So the way that I fixed this is, move this on. Okay, this will move on in a moment. I'm not sure if I've clicked once or twice. Okay, there we are. Okay, so what I did then is I'm downloading the Jupyter notebook, and I'm going to open up Visual Studio Code, and within the Python support, there is now the ability to import a Jupyter notebook. So I've imported the Jupyter Notebook. And you can see, I'm just going to save this first. Save it as PyCon. And then I'm going to run the first cell inside Visual Studio Code. And what you will see is it started up an instance of Jupyter Server on my notebook. I'm then going to run, and you can see that over here it says the cell number. So that go to 45 relates to this item over here. So if I just make a marker, because it's not always that clear. But see where it says go to 45? In the interactive window, that's over there. So you can see the code as it's executing. I'm then going to click on the next cell. I'm going to run the next cell. And what this did is just a Python import. I'm going to run the next cell after that, which is just an imports. I'm going to run the cell after that, and this cell goes and gets the data. Oh no, sorry, just import some libraries. The next cell will go and grab the JSON data from the cloud. So there goes that collection or that list of JSON objects. And then I'm going to debug the cell that I know is a problem. So what I can do now is I can start stepping through the Python code that I've imported from the Jupyter Notebook. So you can see that I'm just stepping through the code, and I've also clicked on one of the variables, and you can see that I can inspect it, and you'll see that it's got the value none in it. So you can see over here it's got none. And I think that might be part of the problem with my Jupyter Notebook, is for some reason it's got none in it. And you can see the y coordinate has some values. So what I've done now is I've inspected item. And you can now inspect, these are all the values that are in that dictionary object that basically got imported from that JSON. I did a JSON loads. So that's how that got there. And you can see in there that I have an item called tag name. If I just highlight that, you can see there I have an item called tag name. But if you look down here, I have a reference to an object in the dictionary called tag. And what happened is that the dictionary name changed, and I didn't know. And this is really common. So what's happened is I've got a dictionary object whose name has changed. So you can see what I can do now is I say, I found the problem. It's tag name. And now you can see when I step through the code, and I go and hover over the X, you'll see that now I have what I expect. I've got green apples and red apples in there. So it's fixed. And that's kind of how that works. And at the end of it, what you can also do is export out to a PDF, the chart. So if I go and run all that now, you'll see that this now executes as I expect. And in the end, what I can do is export that out back as a Jupyter Notebook. And so I can then import that back into Jupyter, and the problem is fixed. And it's so much easier now that you have a proper debugger to go through the Jupyter code. So that's pretty cool. So I hope if you like it, you'll use it. So kind of in summary for this session, what was going on? So I had the camera. The camera was capturing objects. I was using an image classification system from Custom Vision. I was using text translation, and then I was using text to speech. And that's how that kind of intelligent piece of code was executing on the device. I then sent the data up into the cloud. I captured the data using Python functions. I wrote that data into storage, and then I used Jupyter notebooks, and then I debugged those Jupyter notebooks with Visual Studio Code. So hopefully that kind of gives you an idea how that all works. So that's really the end of my session. So I hope you got some ideas out of that. Do try custom vision. It really is amazing. And I would also just encourage you to make sure that you learn new things at PyCon. It's an opportunity to learn things that you didn't know before. But above all, do make sure you introduce yourself to new people and find out what they do and what they know, and maybe you can work with them. I'd also recommend finding a fun project. If you're trying to think, I want to do some more Python, I don't know what to do, find a fun project. Hackster, I don't know if you've heard of a site called hackster.io. They have lots of great ideas up on there. You can find all the resources for this talk up on this link. So aka.ms/PyCon Shanghai. So that's where you'll find the link to all the resources. I will get my slides up there soon. If you have access to Twitter, then do follow me on Twitter as well. So that's the end of my talk, and thank you very much. And enjoy the rest of PyCon. Thank you.
Thanks, Dave. At the same, we gave 2 chances to people ask the question. OK， 我们还是有2个提问的机会，然后谁先来？行好。
The question's from somebody right at the back.
站了。
Yes, thanks so much. Running from front to back, it means your voice travels very far through IoT. Okay, my question is about the IoT device integration between hardware and software. You also apply some object recognition. To what degree do you advise we should do it on intelligent edge cloud, or send the data to the cloud to run all the calculation on there? Thanks.
Trouble is, I couldn't quite hear that. It was very muffled.
Okay, I just paraphrase it simply. You talk about the IoT device in terms of hardware, software integration. You also recommend the object recognition done on intelligent sensor, or the human intervention is involved, coupled with machine learning, or you advise to do it purely on cloud? Thanks.
Okay, I think this was a question about building the model and improving the model. I'm going to go with that. So first of all, I talked about the IoT. So we're running a model. So there are software developer kits which make it very easy for you to go and get that data up into the cloud. We also have something called IoT Edge, which makes it very easy to update the computer vision model, the machine learning model on the device. So the way that works is that you basically, the intelligent edge, the example that I'm showing you, uses something called IoT Edge. And it uses Docker. And everything, all the machine learning is Dockerized. And when there is a new version of the machine learning model, so you need to go and improve that machine learning model, you basically go and rebuild the Docker image, and then you send some data down to the device, and that bit of data tells the system to say there is a new Docker image to go and pull down to the intelligent device, which has the updated machine learning model in it. And that is the process by which, because machine learning models evolve and you need to train them and you get new data into them, and you need a way to be able to get that application down onto the device. So in the case of the Raspberry Pi, I basically had a new Docker image, and that pulled down the new version of the machine learning model. On something like an iPhone or an Android device, you would go and update the application. Did I sort of answer the question? Okay, thank you. Sure.
Is there anybody? 然后还有其他人要提问的吗？然后我们倒计时5秒，
Another question.
还有其他人要？
Another question down there.
哪位？好，来了。在哪儿？
Okay, thanks. I want to ask a question about IoT, and I'm going on that the previous question. What do you think the place that the Python in this area? What I mean is, how do you think the Python should play the dominant place in the area of IoT? Or because I think other language, for example, the Go, may have an excellent performance within the internet connection, or other something other.
Okay.
Okay.
Okay. I think your question is, for IoT and particularly embedded systems, where does Python fit? Where can you use Python for embedded? I think that's what you're asking me. So where I see Python being used for small systems is particularly around prototyping an idea. The reality is, if you're building a system on a very small bit of silicon with a very small memory footprint, so very little memory or processing capability, today you're still going to write that in C and C++. I think in the future that will change, but I think we're a wee way from that. So in China, there is a very popular IoT device by a company called Expressive, called the ESP32. I don't know if does anyone use those? They're a very popular device, and they're capable of running Python. The device before that is called an ESP8266. And that device isn't really capable of running Python and being able to securely connect with a cloud system. So today, you still run and write those in C and C++. But I think that will change over the next couple of years, where where I see Python being used for IoT at the moment is for prototyping an idea. So on a Raspberry Pi, or there's a company called Adafruit, which I know also they sell worldwide, and there is a particular chip called the Atmel chip, which has around about 256 kilobytes of memory and quite a capable processor, which is very capable of running MicroPython or CircuitPython. But they're great for prototyping, but for putting into production, you're still going to write in C and C++. Okay, did that sort of answer your question? Okay, feel free to come up and ask me after as well. So I think we had time for 2 questions, so.
Yes, let's thanks Dave again. 哪怕我们再次感谢一下 Dave 的精彩演讲。
Thank you.